My esteemed listeners, this tutorial comes in sequel to C decision control constructs in general and C decision control constructs 1 in particular. And in this session, we just start from where we left. We have covered 7 examples in the previous tutorial and we will take typical examples concerning if, else ladder, that is multi-decision control construct in C. And we will straight away start with the problem. Let it be some kind of a problem solving exercise. And in between we will look into some of the salient points of the programming language. And in this example, we have developed a program. We will be developing a program. Given a point, a line from the point forms an angle with the horizontal axis, with respect to horizontal axis, and to the right of the line. The line is said to terminate in one of the 4 quadrants based on its angle theta from the horizontal as shown in figure. Write a program that determines the quadrant given a user input angle. So user will give an input angle which will be measured in the anti-clockwise direction with respect to x-axis, and when it is 0, the program should be printing it as positive x-axis. When it is 90 degree, it should be positive y. When it is 180 degree, it is negative x, and when it is 270 degree, it is negative y, and in between you should come out with the respective appropriate quadrant. So the theta, we cannot represent the theta theta by some kind of a symbol, okay, in its right perspective. You cannot represent it like a symbol like this, because this is a non-programmable character. So it can be printed anyway by remembering the ASCII code, but anyway it cannot be used in the program. Therefore it is named as theta. Clear screen is there in order to avoid the screen becoming clumsy after successive execution of this same program repeatedly. So enter the inclination of the line, okay, that is requested by the user, and this particular statement will serve as a user prompt, and it will make the program little interactive. And the theta value is scanned and it is directly compared. If theta equal to 0, the line is positive x-axis. Else if theta is greater than 0 and theta is less than 90, if it falls between 0 and 90, it should come in the first quadrant. Else if theta equal to 90 degree, it should be positive y-axis. Similarly, if theta is greater than 90 and theta is 180 less than 180 degree, it should fall into second quadrant. And if theta becomes exactly equal to 180 degree, line falls on the negative x-axis. And if theta is between 180 and 270, it is in the third quadrant. If it exactly becomes 270 degree, it is negative y-axis. Else printf, it is the fourth quadrant. If all the conditions exhaust, then the line must be in the fourth quadrant. So here an example is tried out. Enter the inclination of the line. It is 180 degree. Line falls on negative x-axis. Okay, this is the first example wherein we involved with several conditions. Now, declare the result of a student in an absolute grading system. That is, the grading system is percentage based, that is aggregate based. Okay, read marks obtained in 5 subjects, each having maximum of 100 marks. So 75% and above distinction, 60 to 75 is first class, 55% to 60% is second class, 40 to 55 is pass grade, and less than 40 marks is fail. Okay, then anyway we have to include stdio.h in order that printf scanf would work, and conio.h in order that clear screen and getch should work. So therefore we have named the subjects as S1, S2, S3, S4, S5, and they are of integer category because marks cannot be float. And the percentage is another value which is calculated, okay, upon adding all these marks and dividing by Fine. So clear screen is placed once again. Enter the marks obtained by student in 5 subjects. And here in scanf we have to put percentage d, 5 percentage Ds without any comma. And if we place comma over here, while giving the input also we should give comma. Therefore, we should not do any formatting as far as scanf is concerned, as far as the input function is concerned. So S1, address of S1, address of S2, S3, S4 and S5. Okay, the percentage marks is calculated, percent equal to, the variable is named befitting what exactly it contains. Okay, S1, S2, S3, S4, S5, add them and divide by 5.0. It is very important to note here, a very important point over here. The sum of this all the marks is an integer, and if had it been 5, just 5, it would have become integer division. And as revealed in our previous discussion, integer division always truncates. It will never give you the correct value. Therefore, it is been, the entire expression is turned into float, and percentage has already been declared as a float. Therefore, we will be getting accurate values against percentage. So printf percentage marks is printed. Okay, 0.2 is the formatting, so it can be just up to second decimal place. Okay, if it is 98.66667, okay, the accuracy to the 6 decimal places. Okay, by default the computer will be printing that up to 6 decimal places. In order to contain this accuracy, we have limited the accuracy only up to second decimal place. Okay, 0.2f is nothing but formatting the float value, the percentage. So the percentage written, this is the variable value contained after calculation will be printed over here. Okay, up to second decimal place. Now comparison is being made, okay, by using relational operators in order to determine the result. If percentage is greater than or equal to 75, it is distinction. Else if percentage is between greater than or equal to 60 and less than 75, it is first class. Greater than or equal to 55 and percentage less than 60, it is second class. And if percent is greater than or equal to 40 and percent less than 55, it is just a pass. Else if all the options exhausted, if all the options gets exhausted, then it should be fail. Okay, and here one input is tried. Enter the marks obtained by student in 5 subjects. It will be printed. Okay, whatever that is in double quotes will be printed, and it is called as a literal. It's called as a literal string. Okay, it is guiding the user as to what he or she should do. Enter marks obtained by student in 5 subjects. So 5 subjects is, so you have to enter 56, press space bar, once again enter 64 like this, or you can enter 56, press enter, it will go down, 64, enter 78, enter 82 and enter 73. Like this also we can give the input while we run the program. Percentage marks obtained is 70.6. Naturally it should be first class because it falls under this particular category. Okay, the second category. Right. The commission given away to a salesman depends on the sales he or she has made. Okay, if it is less than 1 lakh, no commission. If it is between 1 to 3 lakhs, it is 8% of the sales. If it is between 3 to 5, it is 8% up to 2 lakh and 10% for the excess. And if the sales is between 5 to 10 lakh, it is 9% up to 5 lakh and 12% for the remaining. And if the sales is greater than 10 lakh, then it is 10.5% for the entire sales. we need to develop a program for this only to compute the commission. Okay. So here sales could be float because it could be 1 lakh point 90. Okay, 1 lakh point 90 rupees. Okay, commission is another variable. Okay, enter the sales amount in lakhs. So the user will enter the sales in lakhs. He may enter 3.5, 4.5, anything like this. Computation of the commission happens. If the sales is less than 1 lakh, this is as per the conditions given in the problem. If sales is less than 1 lakh, commission equal to 0. Else if sales is greater than or equal to 1 lakh and sales is less than 3 lakhs, commission equal to sales into, this is 8%, 8 divided by 100. Yet again, we need to exercise caution. Had this been 8 by 100, it would have given us given 0, because division will have higher priority. 8 by 100 would have been committed first, and it would have given 0, and commission would have been 0. Therefore, this is made 100.0. Therefore, entire expression becomes a float. Else if sales is greater than 3 and sales is less than 5, it is 8% up to 2 lakh. Therefore, 2 into 8 divided by 100 plus, for the remaining, that is sales minus 2 lakh, this is the remaining amount, into 10, okay, because it is 10% for the remaining. Else if sales is greater than 5 lakhs and sales is lesser than 10 lakh, then commission equal to 9% up to 5 lakh. Therefore, 5 into 9 divided by 100. Okay, this is 9% of 5 lakhs plus sales minus 5 lakh, that is excess of 5 lakh. Okay, if total sales is 6.5 lakh, then excess should be 6.5 minus 5, that is 1.5 into 12%, that is 12 over 100. Else commission equal to sales into 10.5 divided by 100, 10.5%. Then sales done is written like this. It's again rupees. You can notice over here, rupees is written before the answer is printed over here in this format. Okay, lakhs is also written after the money comes, after the commission is placed over here. Okay, up to second decimal place, lakh should also surface. Sales and commission. Similarly, for commission also some kind of a small formatting is done and commission is written over here. Enter the sales amount in lakhs. 6.27 is the amount. Therefore, up to 5 lakhs, it comes under this category between 5 and 10. Okay, up to 5 lakhs it is 9%. Therefore, 9 into 5, 45, that is 0.45 lakhs. Then what remains is 1.27 lakhs. For 1.27 lakhs, here it is. For 1.27 lakhs, it is sales minus 5, that is 1.27 into 12 divided by 100. So this amounts to 6.27 lakhs. Okay, say this amounts to 0.6 lakhs. Okay, and there are very important points to be noted, respected viewers. Okay, as far as if, else if and else block is concerned, and in general if blocks are concerned. Use braces if we have more than one statement under if, or else if, or else. Okay, then if there are more than one statement, it becomes if block, this becomes else if block, and this becomes else block. Do not use the equality operator with a floating point number, because whenever we compare the floating point number, due to round off errors, they will never be equal. Okay, because they will never be equal to the required value. When we need to test for equality, such as number 1 equal to number 2, both of them being float, and both of them are being equal, due to round off errors, they will never match. Use the expression such as if f absolute, that is absolute value of number 1 minus number 2 is less than 0.001. This is almost equality, but anyway, we cannot question if num1 equal to num2, because both of them are floats, and if both of them becomes, let us say 4.5 or 4.48, and this is also 4.48, when they are referred, when they are compared, this will no more be 4.48, or this may not be no more be 4.48 because of rounding off errors. Okay, because the floating point numbers will be accurate up to 6 decimal places of accuracy if it is single precision. The most common error is using assignment operator equal to in place of equality operator. If we use, see here is an example, if A equal to B, in place of 2 equal sign we have used 1, then the computer is going to understand, the compiler is going to understand or translate if A not equal to 0. If A not equal to 0. So this is not a compiler error, instead it is a logical error. Okay, and if A not equal to 0, if it really happens, the program will simply work, but the answers will be disastrous, and it will be pretty difficult to identify where exactly we have gone wrong. So it will be an error to place a semicolon after if expression. If you place a semicolon after if expression, it will die a natural death. It will never get executed. Okay, it is a termination of if statement. The semicolon terminates the if statement, and any statement that follows is not at all part of the if. it is a compiler error to code an else without a matching if. Okay, you cannot write else aloof without if, matching if. This error is created by a misplaced semicolon. So if you see, here is an example. If A equal to B, this is correct, and these brackets are also there, it's also correct, but there is a semicolon. It terminates, it has no meaning. Okay, then printf will be printed. This entire thing will be terminated because this comes under the control of it, and unable to find a matching if, it will flag an error, no matching if. Okay, so this kind of, so here the parenthesis is missing, parenthesis is missing, okay, sorry, and you have to close this and put a semicolon. Okay, it generates compiler error if we forget the parenthesis in if statement. Okay, and we have to write parenthesis in if statement. Okay, it leads to compiler error if space is provided between the relational operators. This should be actually attached, as if it should seem as if it is attached, and there cannot be gap between this greater than symbol and equal symbol, so also lesser than symbol and equal symbol and not an equal symbol. And while writing these four relational operators or comparative operators, we should take care to see that there is no gap that exists between the two characters. The logical operators and requires two ampersands, and or requires two bars or two pipe symbols. It creates a logical error to place only one character, only one ampersand to connote and only one pipe symbol or bar symbol to connote or. It will never connote, because ampersand, okay, refers to conjunction, and this one refers to disjunction, as far as, and they are used like operators, binary operators, bitwise operators. Okay, at the bit level this connotes some meaning, and this will also connote a meaning. Okay, so therefore single operators are bitwise operators and are therefore valid code. And with this we will come to some kind of a end as far as compound if statements are concerned, multidirectional if statements are concerned, and we will further open up. Okay, it is not, another volume is going to come out wherein we will be discussing about switch control statement and some kind of an application kind of a program. Okay, do it yourself. Okay, you can try. Okay, write a program to check if a given year is leap or not. It should be divisible by 4 or divisible by 100. Okay, write a program to check if the given integer is divisible by 7 but not by 5. Okay, you need to frame a appropriate if statement. Evaluate the functions based on the conditions. Y equal to x cube plus 2x square plus 10. If x falls between 1.5 and 7.5, it is 2x square plus e to the power of x. E, in place of e we need to write exp, and we have to include math h here. Okay, for this program we need to include math h, because exponential term is coming and logarithmic function is also coming. Log 2x plus 2x, and we can write it as ln, okay, to represent log 2 base 2. Okay, x is greater than 9.5. So with this I think we have come to some kind of a respectable position as far as use of multi-directional decision control constructs are concerned. In the next session we will talk about switch case construct as well as ternary operators, and then we will take up 1 or 2 application related programs, and we will elaborate on that closes decision control constructs. So until then, bye.